Hey guys, I have your notes here for section 5.5 day 1, and we're going to be solving trig equations. So our answers for the next several days will always be theta equals, theta equals, theta equals. Or if our angle is represented with an x, our answer will be x equals. But we're always finding the measure of the angle when solving a trig equation. So before we get started, I want you to kind of have 3 things in your mind before we get going. Don't forget ASTC. Remember, this is where your trig functions are positive. So all fractions are positive here. Sine is the only positive fraction in quadrant 2. Tangent's the only positive one. Cosine's the only positive one. And remember, every time we get a reference angle, that reference angle is an angle in quadrant 1. Don't forget your unit circles. So sometimes we may have answers that might be on an axis, like an angle of 0, or an angle of 90, which is pi over 2, or an angle of 180, which is pi, or an angle of 270 degrees, which is 3 pi over 2, or an angle of 360 degrees, which is 2 pi. If that's the case, for 0 or 2 pi, my cosine fraction would be a positive 1. My sine fraction would be 0. My tangent fraction would be 0 over 1, which is 0. So don't forget your unit circle. And then, however you have your fractions memorized. Some of you are using the table. Some of you are using the hand trick. Remember, pi over 6, pi over 4, pi over 3. Everything is over 2. Sine are the bottom fingers in a radical. Cosine are the top fingers. Tangent is these fingers over these fingers. We don't do the over 2 when we're doing tangent, because that ends up canceling. All right, so here we go. I've got most of this kind of already set up to go for you to make the video shorter. But feel free to catch up, pause the video and catch up with me. And I will write some things in as we go. So, up here in the steps, we're going to always isolate the trig function on one side first. So sine of our angle, cosine of our angle, tangent of our angle, whatever. And almost every single time we will get more than one answer. Almost every single time. So the first thing you're going to see me do is I have highlighted the trig function. So I've highlighted sine of theta. We need to get rid of the negative 1 and the 2. So I start with the negative 1 by adding 1 to both sides. I get rid of the 2 by dividing on both sides. And I'm left with sine of theta equals 1/2. It's a common fraction. We know that we've gotten a fraction of 1/2 a lot of times. Positive 1/2. What's our angle? So here's the deal. Some of you are thinking, oh, look, I have the fraction. I'm finding an angle. That's that whole inverse thing. I'm going to draw my semicircles. If you thought of that, I like it. I like your thinking, but don't. This problem was not set up as a sine inverse problem. Only if it's written on your paper as sine inverse do you draw your semicircles. So we're not drawing semicircles today at all. And at this point, some of you are thinking, good, because I wasn't good with the whole semicircle thing. So here we go. We're trying to find the angle that has a sine fraction of positive 1/2. The first thing I'm going to ask you is, what's your reference angle? So hand, table, whatever, what angle gives you a reference angle, gives you a sine fraction of 1/2? I think that would be pi over 6. So my reference angle is pi over 6. Now, this fraction is positive. Where could our angle be? ASTC. Since my sine fraction is positive, my angle could be here or here. Okay, so let's answer the question. If my angle is here, what's my angle? That's easy, pi over 6. What if my angle's in quadrant 2? What angle in quadrant 2 has a reference angle of pi over 6? Well, remember, reference angles are made with the x-axis. So if we want this teeny tiny angle right here to be pi over 6, what's all of this? Well, from here all the way to the x-axis would be 6 pi over 6. And you're going to stop 1 pi over 6 short. So your angle in quadrant 2 is 5 pi over 6. Now, we're not quite finished with this problem. I'm going to go back to the directions. It says solve for all values of theta. All values of theta. So, check this out. What angles could have a positive sign fraction of 1/2? Answer. Any angle in quadrant 1 with a reference angle of pi over 6. Also, any angle in quadrant 2 with a reference angle of pi over 6. And some of you are like, wait, what? How can there be more than one angle with a reference angle of pi over 6? What if you go all the way around once and start over? So what you would get is you would get an angle of pi over 6 plus 1 complete revolution. Or you could do another revolution, or another revolution, or another revolution, or another revolution. You could do 10 revolutions and stop with a reference angle of pi over 6. And that angle, as ginormous as it is, would have a sign fraction of positive 1/2. Same in quadrant 2. So because it says all values of theta, we have to keep saying, oh, and another revolution, and another revolution, and another revolution. Here's how we say that. We say pi over 6 plus another revolution n times. Plus another revolution n times. That's our answer. So you need to make sure that whenever your directions say solve for all values, you need to put plus 2 pi n on each of your angle answers. And another revolution, and another revolution, and another, that's what it means. All right, next one. I have highlighted our trig expression. So that's already over. I just want to get rid of the 2, so I'm going to divide. I get cosine of theta equals radical 3 over 2. That's a fraction that's very common to us. Radical 3 over 2, that would look like this on my hand. That's an angle of pi over 6. Again, reference angle is pi over 6. Our cosine fraction is positive. So let's think about which quadrants that would be, our angle would be in. Cosine positive, here and here. So, what's our angle in quadrant 1 if our reference angle is pi over 6? It's pi over 6. What's our angle in quadrant 4 that has this as a reference angle? Well, it's not quite 1 revolution. 1 revolution would be 12 pi over 6. Not quite. 11 pi over 6. And remember it said solve for all values. So plus revolutions plus revolutions. That's what we have to do when it says solve for all values. Okay? Next one, isolate the trig expression. I subtracted 1 from both sides. What angle has a tangent fraction of, I'm going to ignore the negative for a minute. I'm going to deal with it right here, okay? Ignore the negative for just a minute. Deal with it down here. So what angle has a tangent fraction of 1? That would be a reference angle of pi over 4. Okay? Now, let's tackle this whole negative deal. Since there's a negative here, my tangent fraction is negative, so my angle would have to be in AST here or here. Reference angle pi over 4 in quadrant 2. Pi over 4, that's going to be 3 pi over 4. And in quadrant 4, that's not one complete revolution. So one complete revolution would be 8 pi over 4. Stop, don't go that far. 7 pi over 4. Plus revolutions, plus revolutions. Moving on. Okay, this one's a little bit weird. It says isolate your trig expressions. Well, I got one over here and I got one over here. I've got one on both sides of my equal sign. So I'm going to add sine of x to move this one over. And one of these plus another one of these gives me 2 of these. So I've got 2 sine theta. Sorry, theta. Get rid of your radical 2. Divide by 2. And I get sine of theta is negative radical 2 over 2. Reference angle. Forget the negative just for a minute. Forget the negative. Reference angle. Radical 2 over 2, that's going to be pi over 4. Pi over 4. My sine fraction is negative. This is when I want to deal with my negative. I don't want to look at it when I'm doing my reference angle. I want to look at it when I'm placing my angle in quadrants. So sine is negative here and here. Okay? So in quadrant 3, I'm thinking in a denominator of 4. So from here to here is 4 pi over 4. Go a little bit farther. 5 pi over 4. And then in quadrant 4, all the way around would be 8 pi over 4. Don't go that far. 7 pi over 4. Plus your revolutions. Plus your revolutions. Moving on. Oh, this is a good one. Add 1 to both sides, divide by 4. Y'all should be so good at that. My sine fraction is 1/4. What's my reference angle? 1/4. 1/4. Oh no. My table, my hand trick, nothing gets me a fraction of 1/4. Here's what that means. It doesn't mean you can't do the problem. It means your angle isn't a common angle. It's not, I'm going to do degrees here. It's not 30, 45, or 60 degrees. Or the same ones in quadrant 2. It's not 120, 135, 150. It's not any of our common angles. It's one of those kind of yucky angles that we have to find on a calculator. So I'm going to take out my calculator, and we've been going in radians. Let's keep this in radians. It's a little bit harder to do in radians, but we're going to do it. So I'm going to put my calculator in radians. Hold on. Radians. There we go. Ready? If I know the fraction and I want the angle, I'm going to do a sine inverse on my calculator. So I'm going to do sine inverse. Type in your fraction, 1/4. My reference angle is 0.2526 blah, blah, blah. That is a yucky angle, isn't it? You're used to getting like pi over 3 or pi over 4 or something like that there. This is your reference angle. And notice that I haven't even mentioned yet whether this was positive or negative. Okay? So this is an angle in quadrant 1. This is an angle in all my reference angles are in quadrant 1. This is an angle in quadrant 1. Now, since my fraction is positive, that means see, sign, positive, here and here. Right? So, I'm going to ask you 2 questions. The first one's going to be super easy. You ready? This is your reference angle, which is in quadrant 1. Give me your theta from quadrant 1. Yeah. It's that. It is 0.252, and I'm going to have to round it. It was 7 if I round it. And I'll just go ahead and throw that on there so I don't forget, because I kind of tend to forget that sometimes. So that's my angle in quadrant 1, plus a revolution, plus a revolution, plus a revolution, and so on. What's my angle in quadrant 2? Oh, goodness. That's tricky. Well, remember, your reference angle is made with your x-axis. So your angle that we're looking for in quadrant 2 goes almost all the way to the x-axis, but not quite. We're going to stop short. How short did we stop? Well, we stopped the amount of our reference angle. So if this one right here is 0.2527, what's this one? This is the one I need to answer the question, right? How do you get this? Well, you take the whole thing, pi, minus your reference angle. So for quadrant 2, I'm going to go pi minus reference. And my yucky angle's still in my calculator. I haven't touched it. So I'm going to go pi minus answer equals. Quadrant 2. Ready? It looks like this. 2.8889 plus all of our revolutions. All right, I hope you got all that. Next one. So look, this one's a little funny. It's a secant one. My first thought was, ew, yuck, I don't like secant. So I added 2, isolated it, and then I said, I don't like secant. I don't like secant. So don't use secant. What's the upside down version of secant? It's cosine. What's the upside down version of 2? 1/2. You see what I did? I bet you didn't know you could do this. Did you know that you can do anything to an equation as long as you do it to both sides? So I could upside down this side as long as I upside down this side. What's this upside down? Cosine. What's this upside down? 1/2. I upside downed it, if that's a thing. All right. So my cosine fraction is 1/2. My reference angle is pi over 3. It's a positive fraction that puts me here and here. Quadrants 1 and 4. Now let's answer the question. So theta in quadrant 1, well, that's easy. Theta in quadrant 4, all the way around would be 2 pi. All the way around would be 6 pi over 3. Don't go that far. 5 pi over 3. Plus your revolutions. Plus your revolutions. Alrighty. On the back. On the back, I want to kind of show you. So this time my tangent is being squared. So I did a quick rewrite. I'm going to isolate my tangent. So I added 1, and then as I was rewriting, I went ahead and wrote this like this. And I know I've shown this to you before. I would really like you to kind of get in the habit of doing this, because right now, do you know what calculus students are stuck on? They're stuck on a topic where their problem looks like this, or maybe their exponent is an 8 or something, and they don't know what to do with it. They're like, I don't know what to do with this. I'm just like, geez, go back to pre-cal, do a rewrite. This is this. Remember, I warned you, you have to use the parentheses. We're not squaring the angle, we're squaring the entire tangent fraction that's represented here. Okay, so rewrite it. I'm going to divide by 3. I get 1/3. I'm going to square root both sides. See, I'm going to square root this side. That's going to get rid of that. I'm going to square root this side. Don't forget, when you square root both sides, you've got the positive root and the negative root. So, ready? Square rooting a fraction. Square root of 1. Good job. Square root of 3. Yep, we don't know. So, I squared this side. I wrote tangent theta. Plus or minus, plus or minus. Square root of 1. We didn't know what that was. You can leave it like this, or fix it if you want. I think I'm just going to leave it because remember what our end goal is here? Our end goal is to get theta. So, forget the positives and the negatives for a minute. What angle has a tangent fraction of 1/3? What angle has a tangent fraction of 1 over radical 3? That would be, nope, pi over 6. Pi over 6 has that tangent fraction. Okay, now, is my fraction positive or negative? Well, it's both. Ready? So, where is your tangent? Where are your tangent fractions positive? Here and here. Okay, where are your tangent fractions negative? Here and here. Funny. When we go to give our answer as theta, I have to give my answer from all 4 quadrants. All 4. I'm going to have 4 answers. Here they are. Reference angles pi over 6. Quadrant 1. Good job. Quadrant 2. Quadrant 3. Quadrant 4. Oh gosh, do you put the plus 2 pi n on there? I don't know, hang on. Solve for all values of theta. Oh no, hang on. Solve for all values only within 1 revolution. You see how it says that? Only within 1 revolution. That's what that means. Don't keep going and keep going and keep going. Don't put the plus 2 pi in. Only the ones between 0 and 2 pi. Within 1 revolution. Check, we did that. Alrighty, so again, I'm going to isolate. I rewrote. I'm going to divide by 3. I square rooted. Right? Y'all can do all that. That's easy. I said, ooh, I don't like cotangent. I upside downed it. I upside downed cotangent and got tangent. I upside downed this fraction and got radical 3. So, an angle that has a tangent fraction of radical 3, that's going to be pi over 3. My fractions are both positive and negative, so here. All those places. Pi over 3. So I've got quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right. This one's squared also. Add 2, divide by 2. This is what I get. I don't know why I wrote it like that. That's silly. I just told you not to. There we go. Square root both sides. Don't forget your positive and your negative. So I get regular cosine is positive or negative 1. Okay, this is where you need that unit circle. This is going to be like your 4 points on your quadrant axis. So use the unit circle. Where is cosine? Where's my cosine fraction? Where's my x value? Positive 1. That would be here. Where is my x value? Negative 1. That would be here. What are those angles? Well, I think the first one could be 0 or 2 pi. And I think the one over here is pi. Let's see, do I use both of them? What did it say? Between 0 and 2 pi. Well, it kind of doesn't specify. I tell you what, a lot of times you'll see this. You'll see, let your theta. A lot of times you'll see that, and this is a little more specific. If it says this, it'll say, yes, let your theta equal 0, but don't let your theta equal 2 pi. All right? So if these are your stipulations where it says keep it within 1 revolution, if this is what it says, I would eliminate this answer. Okay? But the way that they're worded right now is kind of ambiguous, so I'm just going to leave it there. Okay, and then a couple harder problems. I'm going to kind of go through kind of quickly, except for the weird part. So here, you cannot touch your angle. Up here, the 3 was in the front. It's totally legal to divide by 3. Here, the 2 is attached to the angle. You can't touch the angle. Don't touch it. So you can't divide both sides by 2. So you're like, I don't know what to do. Here's what I want you to do. Pretend for just a minute that where the 2x is, it's just a normal theta. Just pretend it's a normal theta. So we're going to sub in theta for 2x because this is kind of hard. Let's do this instead. This is easier. Here's what my problem looks like. You can do this. Do it. Sine of theta equals 1/2. Okay, my reference angle is going to be pi over 6. It's positive, so we're going to be here and here. So my answers for theta are quadrant 1 and quadrant 2. What did it say? Do I have to put the plus 2 pi in on it? Yep, it did. All values. Okay, put your plus 2 pi in on it, plus your revolutions, plus your revolutions. Once it looks like you're pretty much finished with the problem, now you have to go back to reality. Remember how we pretended for just a minute? We pretended that 2x was actually just theta, and we solved the problem pretending. Okay, it's not theta. What was that to begin with? This, to begin with, was 2x. So, you know what I'm going to do? I'm going to put a 2x right there and a 2x right there. I'm going to keep everything the same. 2x, 2x. You okay with that? I pretended it was theta. I got my answers. I said, oh, no, back to reality. It was really 2x. Now, solve for x. What do you do? What do you do to get x by itself? You divide everything by 2. So I'm going to divide this side by 2. I'm going to divide all of this side by 2. And you know what I get? I get x equals pi over 6 divided by 2 is pi over 12. Okay? What's this term? What's 2 pi n divided by 2? It's just 1 pi n. Do it again. Divide everything by 2. Divide by 2. Divide everything by 2. I get x equals, so when you take 5 pi over 6 divided by 2, it becomes 5 pi over 12. 5 pi over 12 plus, when you divide this by 2, you just get 2n. Just kidding. Just kidding. You get pi n. There we go. Those are your two solutions. And most people do okay with this. Something I have to make sure to tell you though, you have to do your plus revolutions before you go back to reality, because both parts of your answer have to be divided by 2. Okay, next one's kind of similar. Notice that the first thing I did, I got my cosine and my yucky angle. I got it by itself. So I divided both sides by 2. So I've got cosine of weird angle, can't touch the angle, you can't multiply by 2, or you can't change this really in any way, equals negative radical 3 over 2. So I'm not going to change it. I'm just going to pretend for a minute that it's just theta. Sub it in. So easy. You all can do this. Okay? So radical 3 over 2, my reference angle is pi over 6. Cosine is negative, therefore cosine is negative, here and here. That's where cosine's negative. All right? Write down your answers. So, since this is my cosine fraction for theta, theta could be 5 pi over 6, or quadrant 3, 7 pi over 6. Okay, and again, it said all values, so I plus my revolutions. That looks like it would be our answer. Hold on, let's go back to reality. The angle wasn't theta, was it? Nope. The angle was originally x over 2. So, right here, put an x over 2 there. Put an x over 2 there. Where I had written theta, I replaced it with x over 2. And now, solve for x. Basically, I'm going to multiply everything by 2. Multiply everything by 2. So, 2 times this gets me x. X equals 2, or 2 over 1, times this is 10 pi over 6. 10 pi over 6 plus 4 pi n. See, I took the 2 times that, 2 times that. But wait. 10 pi over 6, that reduces. That is an unreduced fraction. We don't want to leave our fractions unreduced. So that would be 5 pi over 3. Let's write that as 5 pi over 3, the reduced version. Okay, and then again, 2 times this, got it, that's going to be x equals 2 over 1 times this is 14 pi over 6. 14 pi over 6. And 2 times this is going to be 4 pi n. But your 14 over your 6 reduces. So let's call that 14 over 6, 7 over 3. 7 pi over 3. There we go. And why did I do those that way? Because I had like an extra number. I had like an extra number in with my angle. It wasn't something I could just divide out on both sides or anything like that. All right, guys. Good luck. Hope this has been helpful.